In this video, you are going to learn mass, weight and density, a chapter of IGCSE O-level physics. You will be able to accomplish a firm grip on the concepts of mass, weight and density. I am an experienced online physics tutor and have done thorough research on these concepts of IGCSE physics. So, let's begin mass, weight and density, our fourth chapter of O-level physics. Starting off with the definition of mass. Excuse me. Mass. So, what is mass? A mass is the amount of matter contained inside a body. Any object in this world or in this universe, the amount of matter contained within that object will be its mass, and the unit of mass is kilograms. Okay, we measure the mass in kgs. Next, we have to define the concept of inertia. What is inertia? Inertia is the ability of a moving object to keep moving, or a stationary object to stay at rest. Okay, so I write it over here as the inertia is the ability of motion of a moving object and the ability of a body to stay at rest when it is stationary. Okay, let's suppose there is a moving car. I draw a car over here like this, and a moving bicycle. Okay, these two objects are moving, but this car has more inertia as compared to this cycle. How? Inertia basically depends on the mass of an object. An object which have greater mass will have more inertia, and the object which has small mass will have less inertia. Moreover, it also depends on the speed as well, but mainly inertia depends on the mass of the object. So if a truck is moving and a car is moving, the truck has more mass as compared to car, so the truck will have greater inertia as compared to car. Similarly, if a truck is stationary and a car is stationary, and the truck will take more force to move from rest as compared to the car, because the truck has greater mass, so it will have greater inertia. It means that when a body is moving or at rest, in order to stop a moving body or in order to move a stationary body, the ability of a body to keep moving or the ability of a body to stay at rest is its property that is called inertia. After the inertia, we will discuss in this chapter the concept of gravitational field. Okay, and the gravitational field. What is a gravitational field? Let's suppose I turn over the page. Let's suppose this is Earth. We all know that Earth attracts the objects towards itself. Let's suppose this is the boundary where the Earth can attract any of the object. these are objects over here, here, here. So this whole region is the gravitational field. So we can define the gravitational field as a region or space around the earth where an object experiences a gravitational pull or gravitational force, and the gravitational force is the attractive force of earth that attract the objects towards itself. Okay, so a region or space around the earth where an object experiences gravitational force is gravitational field. Gravitational field. Okay, moreover, we also define over here the concept of gravitational potential. What is the gravitational potential? Sorry, gravitational field strength, not gravitational potential, gravitational field strength. This is earth, this is the region surrounding earth, there is a mass over here, the earth pulls the mass towards itself. Now the amount of force that is being acted on this mass, that amount of force is basically the gravitational field strength at this point. So let's suppose this is point A. So the amount of force exerted by earth on this mass is the gravitational field strength of point A. Now let's suppose there is another point B over here, another mass at point C over here. Now B will experience more gravitational force as compared to C, and C will experience less gravitational force as compared to A. The mass that is closer to the earth will experience more gravitational force. So the points or region close to the earth will have more gravitational field strength as compared to the points that is away from the earth. So this is the concept of gravitational field strength. I define it over here. The amount of force per unit mass within a gravitational field is the gravitational field strength of that point. Okay, so this is basically gravitational field strength. Now we will relate the two terms, weight and mass. What is the difference between weight and mass? As I have defined earlier, difference between weight and mass. So as I told earlier, mass is the amount of matter contained in an object. Now I will define weight. What is weight? Weight is the gravitational force that acts on an object. Okay, weight is basically the gravitational force that acts on an object anywhere in the gravitational field. Okay, And what is the relation between mass and weight? Weight is equal to mass into gravitational field strength. Gravitational acceleration, not field strength, it will be gravitational acceleration. So for Earth, the value of gravitational acceleration is 10 meter per second square. So the equation will be W is equal to mg. Let's suppose there is a mass of 5 kg. What will be its weight, or you can say in other words, what will be the gravitational force that act on this mass of 5 kg? That will be W is equal to mg. So 5 into 10, it will be 50. The unit of weight is same as the force because it's a gravitational force, so it will be 50 Newton. So this is basically weight. Difference between weight and mass: mass is the amount of matter contained in an object, but weight is the force. Mass is the unit of mass is kilogram, the unit of weight is Newton. I'll add some differences of mass and weight over here. Mass and weight, it is amount of matter in an object, and weight is the gravitational force on an object. Okay, mass, the unit of mass is kilogram, the unit of weight is Newton. We measure mass by measuring balance. And we measure weight, we can measure weight by spring balance. These are some few differences between mass and weight. Now let's move from measuring weight and mass. How we can measure mass and how we can measure the weight. First of all, let's come towards the mass. Measuring mass by using balance. Now we are going to measure the mass. Here is the measuring balance. Okay, let's suppose there is an object O, that we have to measure its mass, and we have some standard masses of 1 kg, 2 kg, 3 kg, 4 kg, 5 kg. Okay, now what will happen? Let's suppose the mass of this object is 2 kg. So if we place the 2 kg weight over here, this spring balance, the needle of spring balance will be at the center. Now what is happening over here? Both have same weight. That means the gravitational force acting on both of these masses is same. So we can negate the effect of gravitational acceleration. So the mass of this object will become equal to the mass of this unknown object. So in this way we can measure the mass of an object by using a measuring balance. Now in order to measure the weight, there is an instrument called spring balance. There is a hook over here. Whatever we have to measure, we hang it over here, and there's some pointers on this measuring balance. When we hang this weight, this spring extends, okay, and needle come, and there is a movable needle that moves along with these readings. So let's suppose this object has weight 60 Newton. So the needle will move 6 units downward at the reading of 6 Newton. So it is very simple, by which we can measure the weight by using a spring balance. After this conversation of mass and weight, we have to move towards the measurement of liquids and solids. How we can measure the liquid and solid, how we can measure the volume of liquid and solid. Okay, so measure the volume of liquid and solid. Let's suppose, starting off with solid. Okay, let's suppose we have a solid, that is a cube, and if we have to measure its volume, then we just measure its length, width and height, and the volume will become equal to length into width into height. But what if there is a solid with irregular volume, with irregular shape? How will we measure the volume of such a solid object? Let's suppose this is a solid object, a stone you can say, and we have to measure its volume. How we can measure its volume? For this purpose we will use measuring cylinder. How? This is a measuring cylinder. This is basically used to measure the volume of liquid that is poured into it. There are some readings of volume at the side of this cylinder. If we immerse water or any liquid in it, we can measure the volume of the liquid. Now, what will we do over here? Let's suppose I do it on the next page. Okay. Okay, what will we do over here? This is cylinder, measuring cylinder. Over here. Okay, this is the first stage and this is the second stage. Now let's suppose there is some liquid in this measuring cylinder and here are the readings. Okay, now initially the volume was 100 centimeter cube of this volume within this measuring cylinder. We poured this irregular object into this liquid and the volume of the liquid raised to a new value. The stone is immersed in the liquid, okay, and the volume raised to a value of, let's suppose, 190 centimeter cube. So from here we can figure out that the volume of this new irregular object that is poured into this liquid is the difference of the volume in the stage 1 and stage 2. So the volume of that irregular object will be 190 minus 100, that will be equal to 90 centimeter cube. So in this way we can find out the volume of irregular objects by using the measuring cylinder. Okay, now what if we have to find out the density of this irregular object? From here we have calculated its volume. Let me remind you the formula for the density. Let me define density for you. So what is density? The ratio of mass over volume is the density of the object. Okay, so density D will be equal to mass over volume. The unit of density is kilogram per meter cube. Okay, or if the volume is in centimeter cube, the unit will become kilogram per centimeter cube. Now over here, the volume of this irregular object is 90 centimeter cube. So in order to find its density, what will we do over here? We will just measure the mass of this irregular object. Okay, so we will measure the mass of this object by using a measuring balance like this. We place some standard weights over standard masses over here and this irregular object over here. So let's suppose the mass of this object is 1.5 kgs, 1.5 kilogram. So the density will become equal to 1.5 divided by 90. So whatever will be the answer, the density will be in kilogram per centimeter cube. So in this way we can find out the density of any irregular objects, and if there is a regular object, then we just take its mass and determine its volume by multiplying its length, width and height and find out the density. So in case of, let's suppose there is an object of mass. This is an object. This is an object, its mass is 3 kilograms. Okay, its length is 2, width is also 2, height is 4. So its volume will become equal to 2 into 2 into 4. It will be equal to 16 centimeter cube. Let's suppose these lengths are in centimeters. So its density will become equal to 3 kilogram over 16 centimeter cube. So the answer will, whatever the answer will be, it will be in kilogram per centimeter cube. So in this way we can find out the density of a regularly shaped solid. So these are the concepts of this chapter of mass, weight and density, where we have discussed the difference in mass and weight, we have discussed about the gravitational fields, and we have discussed about the density. If you have any questions regarding, if you have any confusion or any question regarding these concepts, then just do let me know in the comment section. And this is all about chapter number 4, O-level physics, or you can say IGCSE physics. Thank you.